This is our apparatus for determining the thermal conductivity of copper using Angstrom method. As we see, this is the main unit. We have a copper rod over here which is fitted with a heater on this side. We have a connector over here which is connected to the temperature sensors. There are 4 temperature sensors fitted on the copper rod, and the distance between them can be measured using this scale over here. There are 2 connectors over here. One is for the heater connector. Just make sure the groove over here matches with the notch over here before connecting. Just tighten it like this. This connector is for the temperature sensor. Here are 6 buttons over here. This is the run button. This is the stop button. These are the timer setting buttons. This is timer off increasing button, timer off decreasing button, timer on increasing button, timer on decreasing button. We have a detailed manual over here. This is all the description including the apparatus required, the theory. Here is the formula that we will be using to calculate the thermal conductivity of copper. And next we have the procedure, the observation, and this is the observation chart, and finally the calculations. Let us now proceed with the experiment. We will switch on this main unit. So as you can see in the LCD display given over here, there are 4 temperature sensors T1, T2, T3 and T4. T1 is the sensor which is closest to the heater. This is T1, this is T2, this is T3 and this is T4 which is the farthest from the heater. Next we have the voltage. 30 volt is applied across the heater and we have the current. The current will show when the heater is on. This is the T on, that is the timer on, and this is the timer off which we can set. So for setting the timer on, we have to press this button which increases the seconds over here. So let us set this at 20 seconds and the timer off we will be setting it at say 10 seconds. And we will now press the run button. As soon as I press the run button, the heater is on. Here the current is around 2 ampere and the voltage is around 22 volt. So the heater is switched off. It will be off for 10 seconds and again it will be switched on for 20 seconds. So like this, heat pulses are given at an interval which is specified by the T on and the T off timer. We have to account the number of pulses over a period of time for calculating the thermal conductivity of copper. The formula used is this, where S is the specific heat of the material, that is copper, where ρ is the density of copper, where omega is the angular frequency which corresponds to 2 pi f. Where F is equal to 1 by T and the T is given by the addition of the off time and the on time. And del X is the distance between the 2 sensors or the 2 temperature sensors. And we have phi over here. Phi is the phase difference between 2 consecutive heat pulses and N is the number of heat pulses and T1 and T2 are the ratio of the 2 temperatures. So from this formula we have to calculate the value of the thermal conductivity of copper using Angstrom method. This concludes our experiment. Thank you. Please subscribe to our channel for more such videos. Thank you for watching.